presents a world television premiere. The ABC Sunday Night Movie.
Okay, modeling thick finishes. Thicker finish materials such as tiles, stone pavers, or terrazzo can be applied as unique floor types and modeled where required. For large areas of finish, such as a public atrium or airport terminal, you can assign these materials within the layers of a floor assembly, and we'll do that first. We need to add small areas of thick floor finishes. You may encounter one of two scenarios, with a depressed floor and without. In areas such as bathrooms, a thick set tile floor may require the structural slab to be depressed in order to accommodate the thickness of the finished material. The main floor object in this figure that I'm about to do is going to be cut with an opening at the inside face of the walls. Another floor is modeled with a negative offset value to accommodate the thickness of the tile material. And the tile is in place as a main floor element. Now, there's various ways to do this. If you cannot do that, just a slight depression, in place flush. Select the artificial tab and eliminate the component model in place, choose the flush category and create a void extrusion. We need a slab depression. Remember to use the cut geometry tool to cut the void from the floor before finishing the family. Alright, so let's just do that. Let's just make sure we have this all set up so we can see it in our views. We have a section, longitudinal section. Let's draw another section here. Right over here. Let's drag the back plane. Far cutting plane a little closer, right there. Alright, so it says we can create an in-place floor, right? Architecture. Model in place, floor, right? So we can get into the family editor. Let's leave this as floors, floor. Let's just drag it about that big. And we can actually assign this a negative depth. Well, right now, it starts at 0 and it goes up to 1 foot, and it's a void. So it's going to cut the whole slab out if I was to hit that. So let's just make this 3 inches. Okay, let's test it this way first. Now, I want to get this section open because you're going to see, right, some void forms of this filling do not cut anything and will be deleted. To make a void form cut something else, use the cut geometry tool. Well, there's a reason, because the void form isn't down deep enough. -3 inches, right? -3 inches is where it's going to start down from the level. Let's give it an extrusion end of 3. So it'll bring it up flush to the underside of the floor, and this should cut it. Some void forms, if they do not cut anything, will be deleted. To make a void form cut something else, use the cut geometry tool. Well, it's not letting us. So cut the geometry tool. Cut. select geometry to be cut, or the floor. Select void geometry to cut out, select void geometry to cut selected solid. Okay, now let's see if it cuts it. Okay, so you have to actually cut it, won't cut it automatically. Now let's take a look at that section and see if indeed we have to adjust any variables. Let's go to view, and you see on level 1, well, there it is. It's a floor, right? It doesn't say that it's a void, so you're going to have to look at it. Come over here. Let's zoom this model around. Let's zoom in and see indeed it is a void. If I tab, I'm going to get out of there, and if I tab around and select just that, it's considered a floor, and but you can't tell that it's void. The only reason you can see that it's void is because it cuts it out. Now, that's one way of doing it. If I reiterate that, that's modeling in place, choosing the floor category and creating a void extrusion where you need a slab depression. Just remember that you don't give it a depth, a negative depth, give it a level start of negative, offset from level, positive or negative, and then give it a depth. So if you let's say if you offsetted it from level +1 and gave it a depth of -6, that may work. Or if you offsetted it -3 from the level and then gave it a thickness of 3 in the positive direction, you'll get it cut to the underside of to the flush top of slab. Now, technically, if you brought it 3 inches down and created the extrusion 12 inches up, you would still get that effect. You would have 3 inches cut from the top of the deck, from the cut plane 3 inches below the level, and then you would have 3 inches cut and then an 8-inch void space above that, which would cut anything else that was in its place. But this particular floor slab doesn't have anything above 3 inches, right? All right, if that makes sense to you. Now, the other way is as an alternative. You can create a floor-based generic family that contains a parametric void extrusion. You can download this file, slab depression, as an example of this type of family from the book's webpage. Now, I did that, but I undid the whole entire exercise because I wanted to show you how I did it. So I'm going to see if it's still in here, is loaded in, because it comes in as a generic model. And it's not. The only generic model is COBIE. And I did look up the word. I suggest you do the same. That's the man, COBIE. So the generic model isn't in yet. So we can just go to Insert, Load Family. And you see in the Chapter 14 directory, there's an RFA called Slab Depression. And you see, just by looking at it, it's a rectangle. It has some parameters to it, some dimension parameters. And you're going to see them pop up. I don't need to open it for you to see it. You'll see it. We talked about that, flexing the model. Well, there it is. It came in under generic model, slab depression. So if I go to level 1, and I go by COBIE over here, and I take slab depression, I drag it in, I'm going to get this witness line, or these dynamic dimension variable lines, dynamic snap tracking, if you will. And I'm just going to place it next to COBIE, and I'm going to drag it down, and it just stops. It's inserted, and as you can see in the properties palette, it's just there's the slab depression. If you look under, it comes in under where the furniture and some of the other generic models are in place, landscaping. Just so happens to be built that way as a family. The family category is important. The family category is important because that's where it's going to place it within the family hierarchy. And if it's the wrong category trying to go in from a discipline that you're inserting, you get an error message, wrong family. So it's pain, but you have to create your families, and when you get to that in the next chapter, you have to create your families with these parameters, or they'll be a bit off kilter. All right, so we have this nice slab depression, and it's still in the command. Let's pick on it and take a look at the parameters that were programmed into it. Length Y, length X, and cut depth, which is great, right? So we have an X, a Y, and a depth. Right now it's cut at 3 inches. Let's just drag it bigger here. We have grips, so you can drag it over. Let's bring it to, look at the bottom elevation. If I drag it to COBIE's left foot, now he runs the risk fallen into this open little, God forbid, if it was a shaft, he runs the risk of tripping. And if it was a shaft, we'd have to put right, you have to put up a fence around here, as per OSHA, and put tape and make it highly visible and make it so that no one can lean against it. It has to be OSHA compliant. Even in the event that you depress a slab, it should be painted a little bit for safety purposes. You don't want to trip. Anyway, speaking of tripping, let's not go off on a tangent, transient, a spike. Let's stick with the program. All right, so that's the other way. And then you can build it into the assembly of the floor, right? Finally, if the structural requirements allow a thick finish to be applied to a floor without dropping the structural slab, a finished floor element can be modeled directly in place within the structural tab. Actually, that's another way of doing it. We could just model another floor right into it, right? I mean, there's nothing saying we can't just go to architecture, go to floor architecture, create a rectangle, and just come down here and draw a rectangle and call it a lightweight, call it slab on grade. We can call it whatever we want, right? It's slab on grade, or we can call it, what other kind of a generic 12. We can duplicate the type, right? We duplicate the type, call it a 3-inch depression, 3-inch, just call it 3-inch, 3-inch tile set. Hit OK. Now its default thickness is 1 foot, because if you look, the structure, let's turn this to finish, let's go this to 3 inches. Let's just give this a material category of terrazzo. And hit OK. Hit OK. Hit OK. And then let's see, I think we should be all right. Highlighted floors overlap, well, we're going to know that, right? Well, there it is. It's built within the floor without changing the structure of this floor, which we'll do now. There's absolutely nothing, there's no reason why. We do that here on the first floor. There's absolutely no reason why we can't come into this floor slab. It's regular slab on grade. If we were to look at its properties, its assembly, its structure, cast in place concrete. Well, we could go to structure, insert a layer, change this layer to finish 2 with a cut hierarchy of 5, if you remember the cut hierarchies. 5 won't cut through anything. Then just give this a material. And give it what do we got here? Not much. We can make it wood. We can make it wood veneer, wood flooring, maybe. Let's go with some wood flooring just for ha-has. Hit OK. Hit OK. Every 2 must have a thickness we didn't give it. Let's give this 3/4 of an inch, 0.75. 3/4 of an inch, and hit OK. Hit apply. Hit OK. And as you can see, in this, on the first floor, we go to Fine, and we turn off the shading. Let's go to Hidden Line. Slab edge. Well, if you look at this, hold on. So all that glitters is not gold. There it is. Looking at it the wrong view. Floors only. All right, so as you can see, there's the extra layer on the first floor. Now, if you look at this in 3D, you'll see why this looks like this. If we look at this in 3D, you can get a better idea of why it has that odd shape. Because we put in, if you remember, we on the first floor, we put in that profile, right? We put in that profile that keyed out just this section, right, of the slab edge. So that's why we're getting this this look. And we're not getting it in section, right? We're not getting it in section. All right, so I'm just going to hold that thought for a second. This view has its parameters pretty well set. Floor is only 3D view. I'm pretty comfortable with that. And that's pretty much it now. we can cut the geometry out as well, to actually cut it out, put in a mass in place and create any shape you want and just cut it out. Now, this shaft opening tool, we're going to get into this, but this also is a tool that you could use, and it's going to go into it more in depth soon. But this is good for shafts because the shafts will move on all the levels if the shaft moves. And it's good for any raceway, any type of raceway, piping, conduit, mechanical piping, ductwork, plenums, anything. We'll get to that tool. Anyway, I wanted to stop it there. This is just thick, I'm modeling thick finishes, and where it's more than just a skim coat, if there's going to be a topping slab. And we still haven't gotten into pitching these, obviously for drainage purposes, right? Floors aren't always flat in the X, on the X plane. If you're looking at it in elevation, right? In elevation, sometimes there'll be a pitch. There may be a pitch, like in a shower, right? Or any draining floor, whether it's a drain. And the whole floor doesn't have to be pitched in one direction. On one floor, you can have multiple areas or multiple perimeters that pitch different ways. Just like a roof, right? Just like a roof. The object is just to get the water out using gravity. And in some instances, these floors will pitch up, right? Ramps, and again, there's a ramp tool, as you can see, circulation. But there's also, could be reasons why you want to pitch a floor up. And we'll get to that. But I think that's a good enough segue into ceilings. We still have a lot more to get to. Because we're going to put all this stuff together, understanding advanced modeling methods, advanced shape editing with floors and all of these things. Just like we went into creating complex wall systems. And then we're going to tie it all together. And then we have to start documenting it, right? And then we have to start getting it on paper, annotating it, documenting it, detailing it, call-outs, sections, elevations, notes, and then all the COBIE compliance that has to be programmed into this. When we're talking about bringing in families from manufacturers and getting them on schedules, and then we're going to get into systems eventually, and documenting the systems and scheduling the systems and analyzing the systems, airflow and voltage and pressure and variable air volume and all that good stuff. So speaking of variable air volume, I don't want to talk until I'm blue in the face. Let's stop this one here, and we'll move on as we do. It's 12:03. I got to make a lunch. I got a few things on my itinerary to do today, but I think that's good for now. Hopefully you enjoyed the video. Okay, I'm back. Plugging away. Modeling thick finishes. Thicker finish materials such as tile, stone pavers, or terrazzo can be applied as unique floor types and modeled where required. For large areas of finish, such as a public atrium or airport terminal, you can assign these materials within the layers of the floor assembly. When you need to add smaller areas of thick floor finishes, you may encounter one of two scenarios with a depressed floor and without. In areas such as bathrooms, a thick set tile floor may require the structural slab to be depressed in order to accommodate the thickness of the finished material. The main floor object has been cut, well, in the figure that we're going to be showing you, the main floor object has been cut with an opening at the inside face of the walls. Another floor has been modeled with a negative offset value to accommodate the thickness of the tile material, and the tile has been placed as a unique wall element. Now, it doesn't show you that, but you can discern that from an image. If I just say depressed tile flooring section, I'm sure I can get you the image close to what the book is saying. Right. Okay, so a depressed floor. I'm depressed. No. All right, now, if you do not need a finish, but just a slab depression, you can create it with an in-place void extrusion. Select the Architectural tab in the ribbon and click Component Model in Place. Choose the Floors category and create a void extrusion. We need a slab depression. Remember to use the Cut Geometry tool to cut the void from the floor before finishing the family. As an alternative, you can create a floor-based generic family that contains a parametric void extrusion. You can download the file C14 Slab Depression RFA is an example of this type of family from the book's webpage. Finally, if the structural requirements allow a thick finish to be applied to a floor without dropping the structural slab, a finished floor element can be modeled directly in place within the structural slab, as shown in figure 14.21. The tile floor has been graphically embedded in the structural floor using the Join Geometry tool. To do this, click the Modify tab in the ribbon and click Join Geometry. Be sure to pick the finished floor before the structural floor or you'll get an error. Okay, now, it doesn't go through the steps. The book's not going to tell you how to do it. I'm going to do it, and I'm just going to go through it with you. So, we're going to prepare for that inevitability. All right, now, let's just hold that thought, and let's go back to our REVIT. Okay, remember that we can edit of the floors, right? We can edit the assembly of the floor. Okay, now, hold that thought. I am going to prepare the lesson going forward. Now, just give me a second or two or a couple hours, all depends. I have things to do. But again, this edit assembly dialog box behaves just like the wall, just like all the other dialog boxes that allowed us to dig down a little more granular into these systems. All right, so hold that thought, and I'm going to come back with a demonstration of that. So just hang tight. And remember what you were taught and how you were taught. How taught are you? All right, so modeling floor finishes, page 609. Now, you can apply floor finishes in a variety of ways. Most methods are based on the thickness of the finished material. For example, a thin finish such as carpet might be applied with a split face and paint tools. Split face and paint tools divides the face of an element, such as a wall, into regions for the application of different materials. The split face tool only splits the selected face of the element. It does not result in multiple segments, change the structure of the element. Paint applies material to the face of an element. For quantity reporting and scheduling, materials that are applied with the paint tool are distinguishable from those that are used as the body material of host object elements. To remove paint from an element, use the Remove Paint tool. Now that's an important aspect of it, not just in the aesthetic appearance of the wall, but in the reporting of the amount of surface material you painted on it, which is indispensable. I'll just add that. So, I'm going to read it again. You can apply floor finishes in a variety of ways. Most methods are based on the thickness of the finish material. For example, a thin finish such as carpet might be applied with the split face and paint tools, whereas a thicker finish such as a mortar set stone might be a separate floor type. Now, using the split face for thin finishes. One of the easiest ways to divide a floor surface for thin finishes is to use the split face and paint tools. This method will require a floor to be modeled and an appropriate material to be defined with at least a surface pattern. You can schedule finishes applied with the paint tool only through material takeoff schedules. You can schedule finishes applied with the paint tool only through material takeoff schedules. Material takeoff creates a list of the subcomponents or materials of any family category. Material takeoff schedules have all the functionality and characteristics of other schedule views, but allow you to get material quantities that make up a component assembly. Let's explore this method with a quick exercise. Open the file C4 Design Floor RVT from the book's companion web page. We'll continue to file from the previous exercise and activate the level 1 floor plan. Okay, well, we have level 2, and we have level 1. Let's look in elevation and see. We're at -2 feet. Okay, so we're at level 1, and this is the floor plan over here to the left. You will see an area of the floor that's bounded by a wall and 2 reference planes. Well, there's the wall, and here's 2 reference planes. 1, 2. And it's not bounded by anything in the front. There's no wall. Click the Modify tab in the ribbon. Select the Split Face tool. From the upper right-hand corner of the Geometry panel, and pick the floor and level 1 floor plan. Draw a rectangle in front of the 3 interior walls as shown in figure 14.7. 3 interior walls. Well, there's the 3 interior walls. Draw a rectangle. You can constrain or lock the sketch lines to the interior walls, reference planes, and floor edge. You may do so in this exercise, but use constraints sparingly in larger projects to avoid slower model performance and updating calculation time. So we could lock, and lock these, or constrain them, for lack of a better term. Also notice that you generated a complete rectangular sketch instead of only 3 bounding lines. You do not need to draw the boundary line at the edge of the floor. However, if you do not include that line and the floor shape is modified in the future, the split face may be deleted because it is no longer a closed loop sketch. All right, so that's important, especially if it relies on this edge. Okay, so click the Finish Edit Mode icon in the Mode panel. In the Material Browser, type Carpet in the Filter search. Return to the Modify tab in the ribbon. Select the Paint tool. Let's see what I'm going to pull down. In the Geometry panel, just below the Split Face tool, in the Material Browser, type Carpet in the Filter search at the top. Carpet. Now we have a few. Okay, so this will minimize your choices, allowing you to select carpet tile from the filtered list. Carpet tile from the filtered list. Wait, did I get it? I don't know if I got it, but I think I got it. This will minimize your choices, allowing you to select carpet tile from the filtered list. In the level 1 floor plan, click near the edge of the split face you created earlier to assign the material. Click near the edge. Did I get it? I don't even know. Let's take a look. Let's select it and see if there's material assigned to it. Design floor sandwich, level 1. I don't see anything that's going to lead me to think that there is. So I'm going to see if I realistically render this. Will that make a difference? I don't see anything. Oh wait, well there's the split section. Did I get the floor? Did I get just the split? Split face. Material. Carpet tile. Oh, I didn't. I'm silly. You gotta select it, and then you have to go up top. You have to leave the dialog box. You have to keep it highlighted, and you go to it, and you select it. I forgot that. That's right. All right. It doesn't really tell you that. This will minimize your choices, blah, blah, blah. In level 1 floor plan, click near the edge of the split face you created earlier to assign the material. It's not like you're loaded into the material paint tool, close the dialog box, and then select. You do it within the context of opening the dialog box. Now, Completed application of carpet tile material to a split face of a floor. Click the Done button in the material browser to exit the paint command. And we've done that already. There it is applied. You can see it now. Rendered. You can see it a little better to a certain extent. Okay, so if we hover under. All right, so that's a pretty brief explanation of the split face. Obviously the whole floor was one floor. We could put any variety of textures we want on it, and it'll schedule. So if we want to do a really quick material schedule, see if we can get it to give us what we want, do a quick material takeoff. And if I could do floors, let's see what it gives us. Let's see what parameters, what fields we could pull. Let's see if we can do what do we got here? Material area. Material as paint, and let's just leave those two. And we got material as paint is separated from the rest. So again, we'll get into schedules a little further on down the road, but you can see there's a difference. And there's four. If you look at that, if you think about it, there are now actually four locations that it had to differentiate. The square footage on this side, and this side. So there's now four zones, if you will. All right, so I'm gonna leave it at that, just because I tend to be long in the tooth, and I don't want to sit here and have go off on a diatribe about faces, split faces. Because you know me, I'll remember that in business and when it comes to free, there's always a snake in the grass. So I have to sometimes bring you back down to reality of life and say that in the business world, when we're talking about floor faces and we're talking about curtain walls and facades and reveals and hidden reveals and soldier courses, you have to remember, what about two-faced? Two-faced is a huge part of architecture. Right? In business, in general, two-faced. So I'm waxing nostalgic. C14 design floor. I let it upgrade 2 years, and we're going to keep going. It's 8 o'clock. I've been up since 6 doing this, as usual. But I've got to get this under my belt, because the MVP, I really want to get to the MVP portion. I really want to get to the MEP portion. So, okay, click the architectural tab in the ribbon and select floor slab edge from build panel. This tool is also available from the structural tab. If necessary, orbit the 3D view so you can see the bottom of the lowest floor slab. Pick all four bottom edges of the floor slab at the level named ground. Activate the section view. Okay, well, first of all, let's get to that view. Now, let's close this. Let's see what kind of 3D views we have. Okay, so we have this as our model. So let's just get this in a view that we could utilize. Let's Z8 to zoom all of the viewports and know that we're on the ground. So if we select that floor slab on grade, we can see that's the one that's selected in our plan view. Let's just look at it again from the south, just to have a better idea. Let's view those as well. Set up your viewports. And hit ZA. So I have 3 viewports. We have this guy over here. Does he have parameters? Level 1. Man, Corbu. Okay, well, Corbu. And again, when I come across words in software, I automatically say to myself, well, again, it's an odd name. And there's always, with Revit, I'm not linked to the internet, but there's always something to do with these little words they interleave. You gotta, if you've never heard a word before, you gotta look it up and see if it's it's one of those things. Revit's actually comical sometimes. In any event, I've seen so many things, and I bring it up because I've seen so many things in models. Like in the field, people doing really funny things, even like during the holidays and stuff like that. You'll find some interesting creative ideas in these commercial models that they're actually doing in the field. So Santa Claus with his reindeer on certain levels. You get a model and you're like, wait a second, what is that? Anyway, so it is what it is. All work and no play makes Jack a dull boy. All right, so we have our south elevation open, we have our ground floor elevation open, ZA, zoom extents. And we have this 3D view of the floors. Okay, so click the architectural tab and select floor edge from the build panel. It's also floor edge from the build panel. It's also available in the structural tab. Slab, floor edge. Let's do it from the structural tab. Actually, you know what? Let's follow the directions, Mike. You know me. I'm always trying to reinvent the wheel sometimes. Slab edge. Okay. Pick all 4 bottom edges of the floor slab at the level of main ground. And we've done this. So if we click this one, oops. Did you get it? I don't see this one. There we go. If necessary, orbit the 3D view. I just screwed that all up. I picked the edge, not the floor itself. So let's do it again like this. Pick all 4 bottom edges. 1, 2, 3, 4. Okay, that's a little better. So if we look at this in section, let's take a look. Quick check. House blend. In any event, making early design models. When you first start implementing building information modeling in early phases of the design, the need to emulate drafting methods is often needed to align the schemes with drawing conventions. As an idea is created, there's usually a need to make some generic assumptions about more complex systems to make the overall design intent as clear as possible. How do you translate this so-called conceptual design into a building information modeling process? To bridge the gap between conceptual design and a highly accurate model, we created a single floor type that contained assumptions not only for the floor, but also for the structure and ceiling assembly below. This larger assembly gives a graphic emphasis to building sections without the burden of modeling 3 different systems before they are close to being resolved. The design floor type also gave us the opportunity to create custom slab edges that are voids instead of solids, voids that approximate a design for ceiling shade pockets or other interface conditions. Okay, now, that being said, creating a custom floor edge, you can apply a great deal of flexibility to a floor assembly in early design. As we described previously, you can create a floor for early design phases that accommodates the floor, structure, plenum, and ceiling in a single floor type. You can also apply a customized edge to this type of assembly for more creative soffit conditions as at exterior walls. Okay, so that is relatively, let's see if it's the same as what they've done here. Yes, to a certain extent. Yes, they didn't include the lights. But yeah, that's pretty much it, the design floor sandwich. So you have now a floor type that is conducive to a coordination study, because we've got this volumetric floor sandwich. And as we all know, well, not we don't all know, but to a certain extent, I don't even know. But we know that the systems have to now, in most cases, coexist up in this little sandwich. And so in a lot of cases, it's very little. Square footage and cubic volume are directly related to cost, right? Space. Here's the money. especially in the city. It's crazy. And all the outer boroughs. So, back to this borough. You dirty rat. You can apply a great deal of flexibility to a floor assembly in early design. As we described previously, you can create a floor for early design phases that accommodates the floor structure, plenum, and ceiling in a single floor type, and we can create soffit conditions at the exterior walls. So that's going to be important. Let's run through a short exercise so you can practice this skill. C14 Design Floor, which we have open from the book's web page, or continue with the file from the previous exercise. Select the floor at level 1 and open the Properties palette. Change the type to Design Floor Sandwich. Well, select the floor at level 1. Well, let's get our bearings, shall we? Well, here's ground, here's level 1, and there's the floor. Just make sure in our 3D view that you have the whole floor selected. All right, so now change the type to Design Floor Sandwich. Type selector, Design Floor Sandwich. Okay. Begin a new in-place component by going to the Architecture tab and selecting Component Model in Place in the Build panel. Set the family category to Floors and specify the name as Floor Edge Level 1. You are now in the Family Editing mode, and the ribbon will have different tabs and panels. Click the Create tab and select Void Forms, Void Sweep from the Forms panel. Click the Pick Path tool from the Sweep panel and choose all 4 top edges of the perimeter of the floor at level 1. You can activate the 3D view floors only to complete the picking of all 4 edges as shown in Figure 13. Okay, so let's do that. Let's just get into our isometric view. Let's take a Architecture, Component, Model in Place, Category, Floors, and we're going to call this Floor Edge hyphen level 1 period. Floor Edge hyphen L1. All right, you are now in the Family Editing mode. And the ribbon will have different tabs and panels. Click the Create tab and select Void Forms from the Forms panel. Click the Pick Path tool from the Sweep panel. So we're going to do a Void Sweep. Pick Path from the Sweeps panel.